All right, hey, we have a lot of stuff that we need to cover. Hey, take a seat. Sorry. Okay, today we have I want to cover a couple main things that in our section, right? We started section 3.1. I do want to get back into the whole concept of continuously compounded compound interest. I want to go into simple interest. I do want to do a couple of those examples one more time because I know some people are very interested in like the Ivy League schools and see what the payment is.
Yeah.
We'll look at that today because I know one of the problems they asked for is very similar to that. They talk about money and investments and stuff. So it fits perfect with the example. Just use that type of number. But the big thing here that we're still dealing with is we still have to know how to do exponents or exponential form. So this is the part today where you need a calculator out, and the calculator you have needs to have like e to the x button, or it has to have the scientific keys. Maybe that's the best way I can put it.
So like Casio won't work.
Casio will work. It'll happen. All right. Okay. Here we go.
When's the last time a person went to like an Ivy League school from here?
From here? I have no idea.
Never.
So,
I'm about to see the map as to why Justin.
we had a couple kids that were accepted, but they couldn't go because of price.
Who?
Geez, who were the?
Most people can't afford it. It's like
Um,
63,000.
I'm like, oh, was accepted at double.
Who?
Mine.
I don't know exactly. We had a couple that were accepted to Stanford and stuff. That it was like super expensive. Like there's no way.
Well, Stanford is like the same level, but it's not.
All right. Okay. All right. Hey.
Does it cost money to? How much does it cost to apply?
What?
It's like
That's something I never applied it. All right.
I would do it for fun, but I don't want to just waste.
All right. Hey, real quick. First examples I want to do. I want to talk about how do we use our calculator today to actually type some of these things in. So if you have your calculator out, I'm going to have you type in a couple numbers to make sure we're getting the right answers. So let's start right in on it. I got 3 examples that I want to type in.
3.
That's tuition. Tuition's like 43. Room and board and all of it.
Okay. Hey, these are 3 numbers that I want to, I know this is a little weird. These are 3 numbers that I want to talk about how do you type it in a calculator.
1, 2, 3, 4, 5, 6, 7, 8, 9. Is the first. 0.0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
All right. So if you have a scientific calculator and you're typing this in,
Like that.
you have to type in the base. You can hit the little caret key if you have a certain type of scientific calculator.
Correct.
Put it in parentheses, and then you're going to type in the -4. Obviously, it's going to be a decimal because anything with a negative power means that you're doing this technically. This is what it technically means, that you move the 3 to the bottom that we talked about in the very beginning of the year. Then there's actually 4 3s on the bottom being multiplied together. And so that's why it gives you an insanely small number. Now, what was the number we got?
0.0, 1, 2, 3. No, 0.0.
Oh, 0. Keep going.
1, 2, 3, 4.
Okay.
5.
You're fine.
7,
Okay.
8, 9.
6, 7, 9. It
Alright.
skips the 8.
Oh.
How inconvenient.
All right. Hey, I think the problems will ask for about 4 or 5
It was
decimal
probably
places.
8 and then 9.
So-
We rounded up to 9.
All right.
Yeah.
Are we? Hey, now if you didn't get that number, because maybe you have a different style calculator. Okay. Hey, guys, we gotta stop talking. Let's go. We got too much stuff to cover. I'm gonna give you homework at the end, whether I can get through it all. Okay. The other way you could type this, you could type in the 3. Now, if you have a certain type of Texas or Casio, you can type in the ABC button, and then type in the -4. Make sure that you're typing the negative sign in there. Now, you can use parentheses there on that one as well. I don't know like what character you have on your calculator, but it will actually calculate that.
It just says, oh my god.
Okay, error for yours.
Mine said
So-
syntax error.
Oh, yeah. So, yeah. Hey,
calories, right, Jay?
ABC button won't work, it's an E button, sorry.
Horsepower.
Oh, it's EDX.
It's an E button. It's not the E with the little caret behind it. It's an EE key. Sorry. That key will give exponents. I don't want to use that though. Sorry, I incorrectly said earlier. I want you to try to use the caret key. Because most calculators have it. I don't want you to use the EE because it's going to give you powers of tens and stuff.
Yeah, it's a point.
Yeah.
It's point all.
Yeah, I don't want those. So, all right. So my apologies. Don't use that. The one other key that you have.
Use a carrot.
Hey, the other character you have is an X to the Y key. Some calculators have that. That one will work 100%. If you have the X to Y key, that is a 100% guarantee that key can work. You just have to make sure you put the -4 in a parenthesis. I don't know which one you have. Like these calculators here won't have it. If you have one of mine, it'd be like maybe that one will have it. That one has it as well. All right. Hey, are we good so far?
Yeah.
All right, moving on. Next, 14. Hit the little caret. Type in 1.7. This one you don't need a parenthesis. You can just type in 1.7. You can use the little X to Y key. Same thing. The last one. This is the one I'm worried about. On this one in particular, when you hit the little caret key and type in the square root of 41. If you have one of mine, like the menu driven, you're fine. But if you don't have one, let's say like
Like a
Casio, Caleb, hold yours up. That you actually need to find the square root of 41 first. And so this number,
You got a big old number.
yeah, this number here, you need to figure out what the actual decimal of it of square root of 41 is like 6.2,
Mr. Ward, that's not exact.
3, blah blah
Miss
blah.
Ward,
6.4.
according to you, 8 decimals is not exact enough, and I assume that is rounded.
Yeah, I agree. Okay. Yeah. So when you type that in, I would go as many decimal places as possible just to get accuracy.
You get -29,000.
So it should be somewhat big because if 5 to the 6th power is a very big number. 5 is 5 times 5 times 5 times 5 times. So I'm expecting something big. Now, if you get weird domain errors, number one, you forgot parentheses, you forgot to close one off. Maybe you had too many parentheses in there. Because when you actually type this in your calculator, the square root, sometimes they put a parenthesis in front of it, so you have to close it and make sure it works right. A lot of people sometimes make the error where they put not a negative sign, but they put a subtraction symbol, so it gives them a domain error. Okay, are we good so far?
Yep.
Okay, last problem before I move on.
Okay. Wait, what is he gonna get?
Okay, last one. Okay, e to the 3rd. Now, what this is the natural number.
Ooh.
Okay, the natural number. Now, where this number comes up, it actually comes up with the compound interest problem that we were talking about. What e actually stands for, it stands for this. This is what it actually stands for. That's the compound interest formula, by the way. The natural number comes out when you start approaching, like infinity from a certain direction, and you're plugging into that compound interest formula, it approaches a certain number. Well, most calculators have this automatically set. The natural number is 2.71. It's got a bunch of decimal places after it. It's an irrational number like pi. It happens in nature because of the way that interest works. But this 3 you put on it. The problem is you can't type this in and put a power of 3. So that's why almost every calculator has an E button. I think even some of the very, very basic calculators actually have it as well.
natural log.
I don't have one.
Okay. It's usually above the natural log key. Yeah, so for mine, it's right below the log button. So, yeah, so to get there, you have to, I think it's the natural log button. You have to find this button and E to the X is right above it. So you have to hit like the 2nd key, or shift, that's what I call it. Then when you hit this little LN button, it'll give you an E on the screen with a little caret behind it. Sometimes it'll just give you a box for you to type in numbers. and then you can type in your 3 and hit enter. I want to know what that number is. It's roughly about 8 or something.
20.
Oh, 20?
Oh, and this is
Oh, that's right, because you're doing almost 3 to the 3rd power, so yeah.
20.
20 point,
Oh, 8. Oh, no, I didn't.
oh 8?
Oh, 9.
Okay. Alright, hey, are we good? Alright, hey. We had a lot of stuff to cover, and if I don't get to it, I'm giving you homework no matter what. Okay, hey, we're moving on. Okay, last thing that I want to cover before we get to the interest rate problems.
Exponentials are
Just wait now. Okay, one of the things I want to talk about is graphing any type of exponential problem. The graphs of exponentials, there are certain forms that you need to know. Okay, let me show you this. Let's go a to the x. Okay, and let's call this my function. Okay, anytime you want to graph an a to the x t, or let's say it's like 2 to the x, or it could be any number. A is any number, right? This graph tends to look like this. We talked about yesterday that things grow exponentially. They grow faster and faster and faster. That's the concept. This is what the picture roughly looks like. What I want to talk about today is what happens when you put certain numbers with it. Like for instance, if you took your function a to the x or 2 to the x or whatever it is, and you added a number out back, what that does is it takes the whole graph and shifts it up by whatever that number was. So let's say you added 4. That means you're going to shift this graph up 4 spots, so it's going to look like this. That's what it looks like.
changes your graph a lot.
If you subtract a number out back, then it moves it down. So it'll go down that many spots, whatever C is. So if it's 4, it moves it down 4 spots. So then it will look like this. Okay, those are easy. Most concepts for like graphing, that's one of the easiest. When they put the number on the inside with the x,
Oh gosh, this is weird.
when they put the number on the inside with the x like that, and they put it in parentheses, they usually will always put it in parentheses like that. Now we're moving it right and left. So when they add a c, it's going to go the opposite of what you think it will.
Left.
This concept will actually move my original picture
Wow.
to the left, which I know that's weird because it looks like a plus. You think you go that way, but it's going this direction, whatever c is. So the picture will actually be over here somewhere, which I know is really odd because the reason why it moves it over when you add, let's say they're adding 4, right? Well, the concept is it's moving the 0 to -4. Because when you add -4 plus 4, you get the new 0. So that's why it's going to the left, -4. Okay? Because of the way that they're adding a number in there. Now, when they subtract a number in here, now it's moving it to the right. Those are probably far the easiest concepts that we have for graphing. Now, I'm not going to have you graph on graph paper today. What I'm going to have you do for just the start today, this is our intro into this because we're going to do this more and more in the later chapters. They're going to give you all the pictures, and all you have to do is match which one goes with which.
That'll be nice.
So it's easy. All you have to do is like on problem number 20, tell me it's, oh, this is A, this is the A picture. Oh, on number 15, this is the B picture. That's the one that goes with the graph below. Okay? So they'll give you all the graphs. I think they scroll over to the next page. I think I only picked about 6 of them. Now there's other concepts. Like one of the other things that you're going to have is if they do something like this. If they put a negative out front, that spills the graph over the x-axis like this. It spills it over the x-axis. If they put the negative out front. If they put the negative on the inside with the actual x, like in here, now that picture, it's normally doing this. Now it's going to go the other direction.
Oh!
It goes across the y-axis.
You've got to be kidding.
So this flips it across the x, this flips it across the y. I know it seems a little bit opposite what you think it would be. That's the concept. If you mix those together, then they'll start to do transformations. We're gonna look at that at a later time. Shh, stop talking. I'm not gonna warn people again. I'm getting annoyed. So, what we're gonna look at tomorrow, because we're gonna start graphing on our own, we're gonna start mixing like all 4 of these things together, and we're gonna start looking at actually graphing things by hand, like actual dots. Because on the later problems, like there are story problems we're eventually going to get later that are like realistic story problems we can use. It's nice to plot data to kind of see where it's going. Like, is the number getting bigger? Is it getting smaller? Where is it approaching? Is it approaching 0? That type of thing. Okay, questions with the graphs idea. Does everyone have those notes written down? They're in the book. They have them explicitly written right next to the homework. Like, it's just the next page over. It says, oh, this is graphing, this is shifting it up or down. So,
The negatives get a little funky.
yeah. All right, here we go. Last concept today. This is our last concept before
Homework.
the homework.
Oh, I thought you said we weren't getting homework.
I said I'm giving you homework no matter what today. Whether I covered it or not.
So if we talk, we still.
Yep, still getting homework.
Do we get more?
I may not cover it. So, all
That
right.
would be difficult if
Yep.
we didn't cover it and then we had homework.
All right, here we go. We're doing the interest problems. Now this is the problems we started yesterday. This is what everyone was kind of interested in. No pun intended. The problems, I'm not going to have any simple interest problems in there. The simple interest formula, if you didn't know yesterday, was your amount was equal to the principal times your rate times time. We're not going to have any of those today. Everything is based on compound interest because this problem didn't have exponents. So that's why they avoided it. What we're going to be looking at is compound interest problems. So we'll do a problem kind of like the whole student loan information or credit card information type of thing. I want to show you kind of the levels. I showed you yesterday like my student loan kind of concept, but we'll do a different one. The formula for that, for the amount, is you take principal times 1 plus the rate over n. That's n is the number of times they compounded. And the power is n times t. And n is the number of times they compound or charge you a fee. And then time is how many years. It's always in years. Past when you started. So if you started an account in like the 50s, you'd count from 50s up till now. So that would be the time frame. Why you'd ever do that? Apple tends to do that with their top executives. They give them what they call vested stocks options, where Apple bought stocks years ago, and what they do is when their executives have a really nice performance over a quarter, let's say like Eddie Q's in charge of the iTunes in Apple, when they have a really good iTunes like quarter where they're selling like a ton of different music and movies, Eddie will get certain stocks from whenever Apple bought them. So what they call them is vested stocks. So he knows how many stocks he got in terms of money. He types in what the time frame was, and this is what you'll see on the news all the time, and then this formula will tell him what his stocks are now worth. So like one of the things they just announced the other day was they had their quarter, I think it was the quarter 1 was just announced. iTunes did really well. So all the iTunes executives.
I'm surprised by that because I feel like they make less money off of Apple Music instead of.
Those are still billion-dollar industries. Each of Apple's like things, like iPhones versus iPads versus computers, each one of those separately is a top Fortune 500 company by itself.
Well, I know, but I just feel like they make less money off of the Apple Music than making someone pay for $1.99.
Yeah, I agree. But when you have like a couple billion people on the planet each buying songs, you make a lot of money. So like they just announced the other day that iTunes people got $22 million worth of stock options and they're vested stocks. So that means they use this formula. They gave them stocks that Apple bought years ago as like a bonus. And so that number changes because if the interest or the rates weren't very good, those executives wouldn't make as much money. So that's why it's always like, oh, they just got 22 million. Yeah, because Apple probably held those stocks from the early 90s. So they're getting a lot of money worth of stock. So, but now, compound interest. Okay, let's talk about that. So one of the problems that they talked about was like, what was the number for Harvard yesterday? That we had?
It's like 63,000.
That's a year, or is that per semester?
Year. There's no way that's a semester.
That's for all costs.
All right.
$500,000 by the time.
All right, so let's say it was 63,000 and you had, you're doing that for your student loan, you went for Harvard for 1 year, and the rate that you graduated at was 0.9%. and you're getting charged annually, or monthly, I should say, so that's 12 times a month, because that's what a student loan is. And we're going for 20 years. So this is one of the questions that somebody asked me for. So that's a 20-year loan, that's your time. This is, they're compounding it monthly, that's 12 times a month. If they said quarterly, that's 4 times a year. Semi-annually is twice a year. Yearly is once, obviously. But the idea is that we have a 9% interest, and this is the money that we're investing. Okay, and so we can type this in, and we can see how much money that's going to be. So 12 times that is 240.
Oh my
And
gosh.
1 plus 0.09 divided by 12. This is 1.0075. Now this is going to Harvard. This is the legitimate number, right? For Harvard for 1 year. Okay, this is what we found yesterday online. Okay, so we take that number,
Yeah, that's almost
we put that to
$400,000.
240. Okay, and then we take that times $63,000. So this is 1 year at Harvard, and I'm paying it over a 20-year student loan.
So that's gonna be, you're not 4 years at Harvard though.
Yeah.
Times 4. Well, we're the
Okay, now obviously you're looking at it and going, "Boy, that's insane. That's 1 year at Harvard." That was almost the exact number for you guys now going 4.5 years at Iowa State. Like that's legitimately the number. Okay. Now, why that makes a difference? Well, Harvard's that upper echelon type of school. You get higher jobs when you leave that school. You're not going to Harvard to become a teacher.
You're also not paying
Okay.
$62,000. If you
Yeah.
have a 3,600 or 34.
Yeah. So I mean, they're only taking the upper crust of people. So you're not paying, that total 63,000. Plus, you're not going to Harvard to become a teacher. In fact, you wouldn't even get the student loan for that because they know how much money you make a year and they would deny you. So the idea is that the people that go to Harvard are going for either, lawyers. That's the number one thing that they pump out anymore. There's doctors and there's other major executives for businesses. That's what they pump out.
Well, only like half the presidents are good ones.
Yeah, only half of them. Yeah, because they're all political science majors, right? But the idea is that that's a really big number. But the jobs you get also have that type of pay. So that's how they justify it.
Probably not that typical.
Now, not everyone, but I mean, think about it. Doctor, yeah, doctors get quite a bit. Not in this area.
You make $250,000.
Yeah, but if you go to Harvard and then you're a heart surgeon in New York City, you're making a lot.
You're making $1 million a year without a debt, without it.
All right, questions with that? Now, hey. Okay, the other formula we have not talked about was this one. This is what they call a continuously compounded problem.
Wait, when would you continuously compound?
Savings accounts.
They're continuously compounded.
Yep, continuously compounded per second. The interest rates are really low. That's how they do it.
That mean like $2 last year.
Yeah, it's really low. I think they're like 0.5%. So it's really low number.
I want 9.
So now it matters the amount of money you put in there. So what I'm talking about is like, let's say you have a little savings account and maybe you had $1,000 in it that your parents gave you from years ago, or you collected money over time. And you got a $1,000 savings account. Okay. Well, the rate on a savings account is really low. They change the rates every year. It's about 0.5%. That was like the best it's ever done. So 0.5%. It's this. That's 0.5%. Not even 1%. It's 0.5%. And you're going for, let's say you leave it in the savings account for 5 years. You're not making a lot of money. And again, you do have to file that through taxes, what you're making on that interest. Because that's free money, so that the government gets 30% of it. Yeah, 0.5%. Now, and I'll agree, like it's a couple bucks here and there. It's not a lot, unless you had a really big savings account.
$25.
$25. Okay, so 1,000 times the natural number E to the
I have $1 million.
5 times 0.005. And yeah, it was exactly $25. It was 25.32. So you made $25 over 5 years. And you're like, well, that's not even worth it. $25, I can invest it in stocks and make more money than that. Yeah, agreed. But that's money you didn't have to do anything for, and you got free money for it. Because where that $25 comes from, if you leave your money in your savings account over long periods of time, your bank will start using that money for loans for other people, and that's why you're making
We
money.
learned about that in econ.
Alright,
If you have
so
$1 million, Mr. Ward, over 5 years, you make 25 grand.
25 grand, that's a lot of money.
How
Now, let's talk about this, okay?
I do.
Hey, let's talk about this. The pension fund. Okay, the pension fund. We can reverse engineer this problem, and we can figure out what the pension fund actually has sitting in its account.
A lot.
Because
I thought they had,
a lot.
I thought it was a
Okay, how much money do we know from like last year? How much money did each kid get?
5,300.
5,300 bucks. 5,300?
Yes.
Yeah.
Okay. 5,300.
Per year, it was like 46.
Okay. 46. So we're good.
I was
Let's hey, let's
Last
go five.
year was
Let's go. Let's go 5 grand.
I know that.
Okay, 5 grand. How many kids graduated last year? 100? 80?
It was
90?
like
86.
86. Okay, 86 kids.
I think it was
That was if it was 5 grand a year, and we're talking
but
multiple
not
years.
all
Okay.
some kids got it.
Yeah, but there's kids from all.
There's kids from other year.
Yeah.
Like my
From
brother.
That's what I was
Yeah.
saying, last year didn't.
Let's just look at this number. This is our 86 graduates getting 5 grand apiece that year. That's just 86 kids getting 5 grand apiece. That's $430,000
On interest.
on interest. Because they're not using the money that's in the account. They're using all the interest to pay because that's why the number changes every year because they're adjusting. Because if they can spend all the interest, you don't get charged. It's free money. Because you're spending all the interest, so you can report 0 on your taxes, so you don't have to pay taxes on it. Okay, that's how the pension fund works.
Okay.
So
they invested
that's
in
why
mutual
this
funds.
number changes every year because they want to spend as much money as possible. So this money was plus the money that was in the account. So I'll put A for the money that was in the account originally. It was the account plus this 430, and that's what they spent last year, let's say, because they want to spend all that extra. Okay, so the idea is that this is your principal that you had that was in the account, which is the A number.
We don't know.
That's your A number, which you don't know. And it's e to the 0.005, and that was for, whatever amount of years. Let's say it was over a 1-year period. The idea is that what we're going to be looking at is we're going to be looking at later this year what these are. Like we can actually
Why don't we
figure
do
that
right
out.
now?
Okay?
Can you do the math and
Not yet. We're not going to look at this yet.
Can you just answer the problem? I want to figure it out.
Yeah.
In that account, there's more than $100 million. No,
What? I thought it was like 2 mil.
it's more than $100 million in that account
How did they get that big?
as of now.
How did they get that big?
It's really old.
Because they're just spending the interest only. They're not spending, they don't want to spend the money in the account, they want it to build, so they're just spending interest on it.
I thought that they
So that means
invested in
for
mutual
every
funds.
graduating year, it's just gonna be a bigger and bigger.
Bigger and bigger money. So they don't want to, if they start spending the money in the account, every year that number would get smaller.
I heard it's.
That's why it adjusts every year. Because there's more graduates. It depends on how many kids there are, and it matters on what the interest rate is. I did a calculation a couple years ago when I first got to Garnet. It's about 110 million.
But how did they build it that big though? Because it wasn't that big from the get-go.
No, that was over years of savings, years, and also money from donations and stuff that went to that account. And then they vested it, they let it sit, and then they're only spending the interest. That's why every year it can either grow or shrink because of the interest rate.
So if the interest rate goes up like even a half of a percent, that's a ton of money.
Made it big time. Okay, all right, here you go.
I seem to be gifted like $100.
That's
We
cute.
still got homework. Yeah. All right, here we go.
No homework.
Hey, 396.
Mr. Ward, not on a Wednesday.
Yeah.
Are we testing over W
19 through 24. But ignore that. 53 through 56. 65 through 68. 74 and 81. All right. This is so.
Mr. Ward, at what point in time is this assignment due?
Okay. This assignment will be due on Monday.
What?
Monday. So you have quite a while to do it. It's not overly difficult. A lot of it's just doing simple calculations with calculator, like those first ones we did. The graphs are just matching. The second part, when you get down to like 53, 65, those are the ones where they say you have a certain money in an account, you have a certain rate. What would the answer be in the long run? So you just type in your calculator, hit enter, boom, it spits out an answer.
I heard it's hard to save to be a millionaire, Mr. Ward. You have to invest.
You have to invest. Because over time, taxes will eat away at it.